Hello everyone. Today we're going to be looking at one application of the zero product rule, which is used to solve equations. Oftentimes they can be used to solve quadratic equations. In this case, we're starting with a factored equation. So we have two factors, 1 minus 3n and 3 minus 7n. And the idea is that the entire equation is going to be equal to 0. And what we want to do is set each factor by itself equal to 0 and solve them for the variable that's contained within the equation. So in this case, we're solving for n, and we're realizing that n is equal to 1/3 in the red case, and n is equal to 3/7 in the blue case. So what we would say is that the two zeros of this function are 1/3 and 3/7. And if you were to substitute either of those values for n back into the original equation, you would find that you would get 0 equals 0. So that's a good way to check your work. So the next example we're going to be looking at is a little bit different. It just has two terms, and we're going to actually have to factor the equation. So we see that there is a common factor of 3z here, so we can factor a 3z out from both terms. And what we have left after factoring that out is 2z minus 1. Now, just like the previous example, we want to take each factor and set them equal to 0 and solve them individually. So we're going to set 3z equal to 0, and we're going to solve that for z. And that shows us that z is equal to 0. And in the second case, we're going to want to set 2z minus 1 equal to 0, and we're going to solve that for z. So we add 1 to both sides, and we realize that 2z is equal to 1, and z is equal to 1/2 by dividing both sides by 2. So the two solutions of this equation are z equals 0 and z equals 1/2. This next one is three terms now, and we're going to have to factor it just like we did in the previous example. And we're going to have to solve for y in this case. So this is a standard quadratic, and we're going to want to factor 5 out as a common factor of all of the terms in order to simplify the polynomial for ourselves. When we factor 5 out, we are left with 6y squared minus 5y plus 1 is equal to 0. Now we're going to want to factor the quadratic inside the parentheses the same way we would factor a regular quadratic with an a term that is something other than 1. So in this case, we're going to have to use the AC technique, where we multiply the a term and the c term together. And in this case, 6 times 1 is equal to 6. So we need to find two terms that multiply to 6 and add to -5. And -5 is the b term in this case. So we start by listing the factors of 6 and any multiples of 6 as well. So they can be negative or positive numbers, as long as they multiply to 6. And the objective is to find two numbers that multiply to 6 and also add to -5. So we're going to list out some factors, 2 and 3, 6 and 1. Now neither of these add to -5, so we have to look at some other combinations of numbers. So as we can see here, -2 plus -3 equals -5, and -2 times -3 equals 6. So our two terms are going to be -2 and -3. And those terms we're going to use to break up the -5y b term in the center of our quadratic into the respective -2y, -3y terms. So we're just replacing -5y with those two terms that we just found. And now what we want to do here is factor by grouping. So we're going to look to factor the first two terms inside the parentheses together and the last two terms inside the parentheses. And we're going to factor them together. So when we factor the first two terms, we can factor out a 2y, and we have 3y minus 1 left over. And from the second two terms, it's not entirely clear what we want to do right away. But if we factor a -1 out from both of those terms, we can make the remainder that's left inside the parentheses equal to 3y minus 1, which is what we have in the first set of parentheses as well. And so by doing that, we are now able to factor 3y minus 1 out of the next set of equations. So now what we want to do is factor 3y minus 1 out of the terms inside the parentheses. So when we do that, we're left with a 2y minus 1 in parentheses, and that is going to be multiplied to our other two factors, which are 5 and 3y minus 1. Now, just like we did in the previous examples, we want to set each of our factors equal to 0. So the first one is going to be 3y minus 1 equals 0, and the second one is going to be 2y minus 1 equals 0. Now we're going to solve each of these equations for y. So we add 1 to both sides. 3y is equal to 1. Now we divide by both sides by 3, and we get y is equal to 1/3. Now in the other equation, we're going to add 1 to both sides. And we're going to get 2y equals 1. After dividing both sides by 2, we see that y is equal to 1/2. This gives us two solutions for y. Y is equal to 1/3, and y is equal to 1/2. Now, if we were to graph this equation, we would see that the zeros that we find end up being the x-intercepts of the graph when it is graphed. So here we have 1/3 and 1/2. The next example is a case of the Pythagorean theorem, where we have side lengths represented in terms of x. So we want to identify the hypotenuse and the a and b sides, and we're just going to plug them into the Pythagorean theorem, which is a squared plus b squared equals c squared. After we do this, we're going to want to expand each term using foiling, or the distributive method. So when we distribute these terms, we get x squared minus 2x plus 1. And we get x squared plus 2x plus 1. So now I have a large equation that represents the side lengths of the triangle in terms of x, and we want to reduce this expression by canceling any similar terms. So if we subtract x squared from both sides, we can get rid of one of the x squareds. And if we subtract 1 from each side, we can get rid of the plus 1s. So after doing these simplifications, the equation we are left with is going to be x squared minus 2x equals 2x. What we want to do is subtract 2x from both sides in order to make the equation equal to 0. And so when we do that, we're left with x squared minus 4x equals 0. And what we want to do is factor this equation, just like we did in the other examples. And so we can factor an x out of x squared and 4x. So when we factor x out, we're left with x minus 4. So our equation is x times x minus 4 equals 0. Now, like the other examples, we want to set both of these factors equal to 0 individually. So our first equation is x equals 0, and our second equation is x minus 4 equals 0. We want to add 4 to both sides of this equation to see that x is equal to 4. So we have two solutions, x equals 0 and x equals 4. And we need to verify that both of these solutions make sense in the context of the problem. So we have expressions for the different side lengths, and if we plug x equals 0 into one of our side lengths, we get 0 minus 1, which is equal to negative 1. And the length can't be negative, and it can't be 0. So we are going to have 0 not be a solution for this answer. Now we also want to check 4. So we plug 4 into x minus 1, and we get 4 minus 1 is equal to 3. So that is going to be a valid side length. So x is equal to 4 is going to be the only solution for this problem.